Hey guys, this is going to be our video for section 5.6 from our textbook, which is another way to solve quadratic equations. We have all these different methods because sometimes one will be easier than the other, sometimes we'll need to use one and not another. So this one is at least a little familiar to you. You've seen this before. There's a big equation formula on the screen right now, and I would highly recommend you writing it down. It's called the quadratic formula. As I mentioned, I know you've seen this before. You might have even heard it before. It looks long and intimidating. It's really not that bad. X equals negative b plus or minus the square root of b squared minus 4ac, and it's all over 2a. And if you've heard the song before, the way that I like to teach people, and many people like to teach people to remember this formula, is Pop Goes the Weasel. It actually goes really well with Pop Goes the Weasel. So you're going to have to survive my singing for the next 30 seconds. But if you're trying to memorize and remember this formula, quadratic formula, you can think of it to the tune of x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And there it is. It goes like perfectly. I think the song was actually written for math. That's just my personal opinion. But that's the quadratic formula, and it's something that you want to have in your back pocket for sure. Now, on the right-hand side of the screen in red, I've also labeled the discriminant. The discriminant is a part of the quadratic formula. Specifically, it's the part underneath the radical, underneath the square root sign. So b squared minus 4ac is the discriminant, and as we're going to see in some of these problems, it can actually give us some really useful information about how many solutions there are, types of solutions, things like that. So some pretty simple instructions here. Find the discriminant and solve using the quadratic formula. One thing I should mention is, as is the case with many of our other strategies, to solve using the quadratic formula, we need this to be equal to 0. So x squared plus 6x minus 16, we'll just move the 16 over, equals 0. So now's the part where let's find the discriminant. Discriminant, I'm just going to label my work saying d. It's that inside the radical part we said, so b squared minus 4ac. So b was 6, so 6 squared minus 4 times a was 1 times c was negative 16, 36, and then it looks like it's going to be a plus. I like to analyze the sign first because we have a minus times a positive, so negative times a positive times a negative. This looks like it'll be plus, and I can just confirm that on my calculator and say, what is negative 4 times 1 times negative 16, 64, which means my discriminant equals 36 plus 64, 100. So my discriminant equals 100. Discriminant equals 100. That's the first part of the problem. The second part says actually solve using the quadratic formula. So here we go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And you laugh right now, but I mean, it gets stuck in your head and you remember it. So x equals negative 6, because that was b, plus or minus square root of, guys, we already figured out the discriminant. I'm not going to do b squared minus 4ac in there. I'm just going to put 100 because we already figured it out. So x equals negative 6 plus or minus square root of 100 all over 2 times 1. And if we simplify this, it will give us the solutions to this equation. So let's do that. X equals negative 6 plus or minus, what's the square root of 100? 10 over 2. So x equals negative 6 plus 10 would be positive 4 over 2. Negative 6 minus 10 would be negative 16 over 2. And so I'm going to come over here because I kind of intruded on the next problem. X equals 4 over 2 is 2. Negative 16 over 2 is negative 8. So from the quadratic formula, we can find those solutions. Pros and cons. Pros. It's pretty straightforward. It's pretty plug and play. Plug in your B and your A and your C and just see what it comes out to. Cons, it can get a little tedious, like just simplifying all that, especially if the numbers aren't super nice. But let's try another one. X squared plus 22x plus 121 equals 0. So I'm going to start by finding the discriminant. Discriminant equals whatever was under the radical, so b squared minus 4ac, or 22 squared minus 121. This is what I'm definitely using a calculator for. 22 squared is 484 minus 4 times 1 times 121 also equals 484. So my discriminant in this case equals 0. Now that's kind of significant. We're going to talk about that a little later on in this video. But right now, let's just see what it does in our quadratic equation. X equals negative 22 plus or minus square root of 0. Because we already found the discriminant, we don't need to do it again. All over 2 times 1. So there we go. We have x equals negative 22 plus or minus, what's the square root of 0? 0 over 2. Negative 22 plus 0 is negative 22, so negative 22 over 2. But think about negative 22 minus 0 will be the exact same thing, right? So here's one of our equations that only has one solution. And if we simplify it, it looks like negative 11. We didn't do the second case, the second solution, because plus 0 minus 0, it's not really going to change anything. So x equals negative 11 there. All right, couple more. Find the discriminant of x squared minus 8x plus 9 equals 0. Discriminant, b squared minus 4ac. So, negative 8 quantity squared minus 419. Negative 8 squared is the same as 8 squared because they're both going to be positive. So 64 minus 4 times 1 is 4 times 9 is 36. So the discriminant here, 64 minus 36 equals 28. What does this mean for us? Let's check. X equals, careful here, keep an eye on your signs. X equals negative 8, because b was negative, plus or minus square root of, already figured out that it was 28, all over 2 times 1. So how do we handle this? That means we have x equals positive 8 plus or minus something over 2. How do we simplify root 28? Well, you guys know how to simplify that square root. Square root of 28, that's 4 and 7, that's 2 and 2. So 2 root 7. So x equals 8 plus or minus 2 root 7 all over 2. And kind of like we've seen before, say with those complex numbers, we can separate this out. X equals 8 over 2 is just 4, plus or minus, the 2 root 7s over 2, the 2's cancel, 4 plus or minus root 7. You might say that's a really ugly answer. I would argue, I would say it's actually a beautiful answer. I know it doesn't simplify perfectly, but 4 plus root 7, 4 minus root 7, quadratic formula works every time, kind of like completing the square, another one of our methods. I mean, we never would have found 4 plus root 7 on our graph. We would not be that exact. So this is a great solution there. One more. Discriminant. B squared minus 4ac negative 6 squared minus 4, 110. So 36 minus 40. Discriminant, negative 4. Negative 4 here. So now, in my problem, in my whole quadratic formula, x equals negative 6 plus or minus square root of negative 4, because that's what the discriminant was, all over 2 times 1. X equals positive 6 plus or minus, what is the square root of negative 4? Yeah, they're back. Imaginary numbers, right? Square root of 4 is 2. So negative 4 would be 2i. And if you need to review those imaginary numbers and such, I'd recommend going back and looking at that 5.4.1 video, how the square root of negative 4 is 2i. And I'll demonstrate it really quickly here. If we're trying to find the square root of negative 4, that's negative 1 and 4. That's 2 and 2. We have a pair here, so we can say plus or minus 2 times the square root of negative 1 because it was left over. But what is the square root of negative 1 defined as? Plus or minus 2i. So we get 6 plus or minus 2i all over 2. Let's just separate them out. 6 over 2, 3, plus or minus 2i divided by 2, 3 plus or minus I. We've got imaginary complex solutions now. So we worked these 4 problems, finding the discriminant each time, and then plugging it into our overall quadratic formula. There are a couple reasons we do it in that order. The first one, finding the discriminant kind of makes our life easier when we're actually plugging into the quadratic formula. Because we don't have to worry about that b squared minus 4ac part. We already figured it out, as you heard me sing over and over again. But the other reason we really like to find the discriminant first is it tells us what kind of roots we have. And I want you to think about this. And really, don't just try to memorize the rules, but think about the discriminant is the part under the square root. So in our class, we're going to kind of group these first 2 rows together. If the discriminant, b squared minus 4ac, if it's greater than 0, if we get a positive number, can we take the square root of a positive number? Yes. Yes, we can. We can take the square root of a positive number, and sometimes, if it's a perfect square, we can take the square root and it'll give us 2 really nice numbers. Sometimes, if it's not a perfect square, we'll get 2 real but irrational roots, meaning they're not nice whole numbers, their decimals go on forever, can't really be simplified. So we saw a couple of those situations up here. The first and third problems, the discriminant was 128 respectively. So again, on this first problem, same problem from above. You don't need to write it down again necessarily, but the discriminant was 100. And so what does that tell us? It tells us, well, it's a positive number. I can take the square root of that positive number. I'm going to get 2 real roots. So 2 real roots. And like I said, I'm not too worried about the rational, irrational at this point. We know we're going to get 2 real roots. On the third problem, we got that the discriminant was 28. Positive. It won't come out beautifully. We saw we had some square roots of 7 in our answers, but it's still 2 real roots because we can take square roots of positive numbers. So again, it came out as right there, 4 plus or minus root 7. It didn't come out beautifully, but they are real solutions. What if our discriminant came out to be 0? That means there's only 1 root and it's a real root. And if you remember, why was that? up here to green, when the discriminant was 0, we kind of had the conversation plus 0, minus 0, because the square root of 0 is 0. It doesn't make a difference. And so we only got that one root, x equals negative 11. So if the discriminant is 0, we can immediately say, oh, discriminant is 0, that means there is one real root. And then finally, what if the discriminant was less than 0? What if it was negative? Well, we know now that we can take the square root of negative numbers, as we did up here, but it will give us imaginary or complex roots. And so if the discriminant is negative, you can see that tells us we have 2 complex roots. And so right here we had discriminant equal, I think it was it negative 4? It was negative 4. Because it's negative, that immediately tells us that we're going to get 2 complex non-real roots. So this is the other reason we look for that discriminant. Not a huge thing, because like sometimes you'll just plug it in and see what kinds of roots you get, what kinds and how many. But it's a nice thing to be on the lookout for. It can save you a little bit of time. Sometimes questions will just ask, how many roots does this have? What kind are they? We can tell that from the discriminant. If the discriminant's positive, we have 2 real roots. If it's 0, we have 1 real root. If it's negative, we have 2 complex roots. So just to kind of wrap up chapter 5, we're not done. We got 2 sections left after this, but showing all these different strategies we had to solve quadratic equations. We had graphing, which works sometimes. Works when there are really nice numbers and when we have graph paper and are super careful. But it's not, I mean, in my opinion, it's not the greatest method because it's only usable sometimes and it's not very precise. Factoring, I love factoring. That's my favorite method. But it also can only be used sometimes. And what does that mean? Well, if the numbers are nice and it works out that it can be factored, great. But sometimes that isn't the case. It's really quick and easy. I usually check for it first, but you can't always do it. Square root property is kind of tied in there with completing the square. Square root property you can use if it's a perfect square on the left. Completing the square, as was shown in that video, you can always use completing the square because you can make it a perfect square and then solve. That's a pretty good solution as well. Quadratic formula always works. Can sometimes be a little bit much, but I mean, if you look at the example there on the screen that I'm circling, I don't want to deal with those decimals when I'm trying to complete the square, or I can't factor it or graph. So quadratic formula is kind of a nice fallback. It always works, it's plug and play, but it has a lot of spots we could mess up kind of with those details, negatives and things like that. So these are 5 different methods we have to solve quadratic equations. Some are going to be more useful than others. Some will be able to be used whenever, some can only be used in certain situations, but it's good and it's important to know how to use them all, not just so you can solve quadratic equations, but these are kind of the building blocks for some other concepts we're going to be learning later this year in future chapters. So hopefully quadratic formula was kind of nice and easy for you. You've seen it before. It's just plug stuff in and simplify. If you had questions, let me know. Give it a try on all those practice problems. And then, yeah, let me know if there's anything I can help with, anything I can clarify to you and the class. But until then, that's it for this 5.6 video. Enjoy the quadratic formula and singing Pop Goes the Weasel lots and lots of times.